One of the first factoring techniques you should try when factoring polynomials is to check if there is a greatest common factor, or GCF. The GCF is the largest term that is a factor of all terms in the polynomial. You can also think of the GCF as being the largest number or factor that you can divide out from each term in your polynomial. Also, when factoring out a common letter or variable, you should choose the one with the smallest exponent. Let's look at some examples. In the first example, 9z minus 18, we can see that the problem can be rewritten as 9 times z minus 9 times 2. We can see that the greatest common factor, GCF, here is the 9. So factoring out the 9 from each term will give you z minus 2. However, it is important that you write your answer as 9 times the binomial z minus 2 in parentheses. To check your answer, you simply use the distributive property to multiply the 9 to the binomial z minus 2, which gives you 9z minus 18. Remember, your answer should be equivalent to the original problem. In the next example, we have 9x squared plus 12x to the third power. We can rewrite the problem as 3x squared times 3 plus 3x squared times 4x. We can see that the GCF is 3x squared. Notice in the GCF we use x squared instead of x to the third power because we choose the one with the smallest exponent. If we factor out the GCF, we get 3 plus 4x. So the final answer is 3x squared times the binomial 3 plus 4x. In the last example, we have 24m to the third power n squared minus 18m squared n plus 6m to the fourth power n to the third power. Again, we rewrite the problem and notice that the GCF in this case is 6m squared n. In this example, we had two variables, m and n, in each term. So for each variable, we choose the one with the smallest exponent and include it in the GCF. After factoring out the GCF from each term, we obtain as the final answer 6m squared n times the polynomial 4mn minus 3 plus m squared n squared. When given a polynomial with 4 or more terms, we factor by using the grouping strategy. Basically, you group your terms and factor out a GCF from each group. Let's look at some examples. In the first example, we have 6p minus 6q plus rp minus rq. We can group the first two terms together because they have the 6 in common, and we group the last two terms because they have the variable r in common. In the first group, notice that the 6 is the GCF for those two terms. So we factor out the 6 and rewrite as 6 times the binomial p minus q. In the second group, notice the r is the GCF, so we proceed to factor it out and rewrite as r times the binomial p minus q. Notice that the binomial p minus q repeats or is a common factor. This means that it is the GCF too. So again, we can factor out this GCF and obtain our final answer, which is the binomial p minus q times the binomial 6 plus r. In the example again, we have 4 terms, so we factor by grouping the first two terms and the last two terms. In the first pair, we see that 3 is the GCF, so we factor it out and obtain 3 times the binomial x minus y. In the second pair, we see that negative a is the GCF, so we factor it out and obtain minus a times the binomial x minus y. Again, we see that the binomial x minus y is a repeating or common factor, so we can factor it out to obtain the final answer, which is the binomial x minus y times the binomial 3 minus a. In the last example, we have 6ax plus 12bx plus a plus 2b. Again, we group the first two terms and the last two terms. In the first group, the GCF is 6x, so we factor it out to obtain 6x times the binomial a plus 2b. In the second group, notice that the only factor common to both terms is 1. So this is the GCF, which we factor out to obtain 1 times the binomial a plus 2b. If we look one last time, we see that the binomial a plus 2b is a common factor. So we factor it out to obtain the final answer, which is the binomial a plus 2b times the binomial 6x plus 1. When you are given a polynomial that has 3 terms, we can factor by using the no-fuss method. In order to use this method, be sure that the polynomial is written in the form ax squared plus bx plus c, where the a, b, and c are real numbers. Let's look at an example. Here we have x squared plus 2x minus 35. In step 1, we list the values for a, b, c, and ac. Recall ac means a times c. And in this case, a equals 1, b equals 2, c equals negative 35, and ac equals negative 35. For step 2, write two sets of parentheses. Notice that the first term in your polynomial is x squared, which means x times x. Since you have multiplication of two x's, we can write one x in each parentheses. In step 3, we draw a large plus sign with a circle at the top and bottom. The left side of the plus sign we label as AC, and on the right side we label as B. Since we listed what AC and B are from step 1, we write these values under the AC and B in the picture. Recall AC is negative 35 and B is positive 2. Next, we need to come up with two numbers to fill in the circles. Notice that the two numbers need to multiply to give you negative 35 and add to give you positive 2. The two numbers we need are 7 and negative 5. Write these two numbers in the circles. For the last step, step 4, we basically take what we had in step 2 and fill in the two numbers we got from step 3. This gives us the final answer, which is the binomial x plus 7 times the binomial x minus 5. If you would like to check this answer, you simply multiply the two binomials together, which should give you the original problem. Here's another polynomial with three terms which we can factor by using the no-fuss method. Notice that in this case, a is not 1. This means that we will see something extra going on in steps 1 and 4. Let's work through this example. Here we have 12x squared minus 5x minus 2. For step 1, we list the values for a, b, c, and AC. In this case, a equals 12, b equals negative 5, c equals negative 2, and AC equals negative 24. Step 2 is to write two sets of parentheses. Again, the first term in your polynomial contains x squared, so we can write 1x in each parentheses. Notice that the a term is not 1, but 12 in this case. When your a term is a number bigger than 1, you need to write this number in both parentheses, just like you did with the variable x. Now, you may be thinking, why do we use two 12s since we only have 1 in the problem? For now, just write 12 in both parentheses. You will see later in step 4 how we take care of this. In step 3 again, we draw a large plus sign with a circle at the top and bottom. The left side of the plus sign we label as AC, and on the right side we label as B. Since we listed what AC and B are from step 1, we write those values under the AC and B in the picture. Recall AC is negative 24 and B is negative 5. Next, we need to come up with two numbers to fill in the circles. Notice that the two numbers need to multiply to give you negative 24 and add to give you negative 5. The two numbers we need are negative 8 and 3. Write these two numbers in the circles. For the last step, step 4, we basically take what we had in step 2 and fill in the two numbers we got from step 3. This gives us the binomial 12x plus 3 times the binomial 12x minus 8. Notice that this is not the final answer. If you look inside each parentheses, notice we can factor or divide out a common factor. For example, in the binomial 12x plus 3, we see that both terms can be divided by 3. In the second binomial, 12x minus 8, we can divide out 4. We proceed to divide out these common factors. Note that if you were to multiply the two common factors 3 and 4, you would get 12. Hence, by dividing out the 3 and 4, you have essentially removed the extra 12 we inserted back in step 2. So our final answer is the binomial 4x plus 1 times the binomial 3x minus 2. If you would like to check this answer, you simply multiply the two binomials together, which should give you the original problem. Keep in mind that there will be some polynomials that you will not be able to factor using these methods. When this happens, you should try the special factoring strategies discussed in the next video. If none of the strategies work, then we say that the polynomial is not factorable or prime. You should look over the examples on the web page and then test your knowledge using Test Yourself.